Atoms in the periodic table. Parts of an atom. The nucleus of an atom is made up of protons and neutrons. The majority of the mass is in the nucleus. It's really, really dense. The electrons are what creates the volume of the nucleus by moving around the nucleus, and that's what creates the size. So it's kind of like blades of a fan. You know how when a fan is on and the blades are going really, really fast, it looks like a circle even though you know it's blades? That's kind of like an atom, is that the sphere is created from the movement of electrons. So essentially what that means is that atoms are mostly empty space. So as you can see here we have the nucleus. You can see in comparison it's really, really tiny. And then you have the electrons around here, and you can see that the electrons, they give you these little paths so you can see which directions they move in, and that's what creates the space. But it's these little electrons moving really, really fast that create this shape and the volume of the atoms. So because these are so tiny, the atom is mostly considered empty space. So you can see the nucleus in the center is considered to be really, really small in volume, but very, very dense in mass. So here you can see a fan. On the left side, you can see the fan, it's stopped, and you can see that the blades are stationary, and you can see all the space in between the blades of the fan. Now, on the right side, the fan, the blades are moving really, really fast, and it gives it a look that it's a circle, that it's taking up all the space. But it's really not taking up all that space. It's just looking like it is because it's moving so fast. So the electrons are very similar because they move really fast, so they create the space. So it looks like they're taking up a lot of space because they're moving so quickly. So protons, you can see right here, this is the abbreviation for a proton. It's a P with a little tiny plus in the upper right-hand corner. It has a positive charge. The mass of a proton is 1 AMU. AMU means atomic mass unit. So it's 1 AMU, or 1.67 times 10 to the negative 24th gram. A neutron is abbreviated as n to the 0 power, or like a little 0 in the upper right hand corner, and that's because a neutron is neutral. It has no charge, but its mass is equivalent to a proton. The electron has a negative charge. It's an E with a little minus sign in the upper right hand corner. It's the smallest of the subatomic particles. Subatomic just means, now if you think about it, the prefix sub meaning below, so below an atom, so subatomic just means the things that make up an atom. So it's the smallest out of the three. Its mass is 9.11 times 10 to the negative 28th grams. Now its weight is nothing compared to a proton or a neutron, so we don't ever use it in the mass. So it's kind of like if you were standing on a scale and you're weighing yourself, and all of a sudden a little fly comes and lands on you. Now the fly has mass, but when you're looking at your weight on the scale, your weight's not going to change, because compared to you, the fly's mass doesn't matter because it's so much smaller. So that's the same thing with electrons, is that they're so small in comparison to protons and neutrons that their mass isn't counted. So ions and isotopes. An ion is an atom or group of atoms that has a charge due to the gain or loss of electrons. And then an isotope is are atoms of the same element that have the same number of protons but different numbers of neutrons. So that is meaning it has a different weight. So notice you can have an ion, which means you have a different number of electrons. And then you can have an isotope, which means you have a different number of neutrons. What is the only thing that stays the same in the atom? The protons are always the same. If you change the protons, you change the atomic number. which means you will change the element. So the one thing that is always constant in an atom are the number of protons. So using the periodic table, so elements are organized in order of increasing atomic number. Originally, Mendeleev put it in order of atomic weight. The reason why they had to be reorganized is because iodine was originally, if you look at iodine and the element next to it, I believe it's tellurium, the masses are different, and so if you put them in order of atomic mass, those two elements will be switched. So it doesn't really work because iodine is very similar to bromine and chlorine, so it needs to be in the same family. So the periodic table was reorganized by atomic number. So across each row, there are patterns that occur across the periodic table, like size, which would be the volume, not the mass. So the size, the electronegativity, and the ionization energy, which we'll learn more about later. And then atoms in the same family or group, which are the same column, have similar chemical and physical properties, which means that they will look similar and they'll react similar. So remember, a row goes across and a column goes down. So it's very important that you know the difference between rows and columns in this unit. The atomic number is always a whole number. It tells you the number of protons and electrons in an atom. So the number of electrons will be different in an ion because remember, an ion means that you add or subtract electrons, and that's how an atom gets a charge. But when the atom is neutral, the protons and electrons will be equal. So this is true for an atom. Remember, whenever you lose or gain electrons, we're not talking about an atom anymore. We're talking about an ion. And the atomic weight or the atomic mass is the decimal. And it's a decimal because it's an average of all the isotopes for that particular atom. So you have like oxygen has a mass of 16.00. If you were to look on a different periodic table, it would actually be 15.9994. So oxygen has different isotopes. You can have oxygen 15, you can have oxygen 16, 17, 18, and 19. Now the most common isotope is going to be the isotope that is closest to the mass that you see on the periodic table. It doesn't mean that the other ones don't exist. It means that they are more rare. So the mass of an atom is the protons plus the neutrons, and that will give you the mass of the specific atom. So this is the specific atom or isotope. So when you look at a periodic square, different periodic tables will have different notations, and they'll have the mass number and the atomic number in different places. Now remember, you always know the atomic number because it's usually going to be the smallest in the square. So the square on the right is more basic. So you have the atomic number, which is the whole number. You have the mass number, that's the decimal, and those are the only two numbers in the square. Now remember, the decimal is always going to be your mass, and your atomic number is always going to be a whole number. Now if you look at the one on the left, the atomic number is in the same spot, but the mass is below, and then you have this number here, which is 14. In this case, this periodic table, 14 is the highest isotope of carbon. So different periodic tables will give you different numeric values, but you always know the mass because it's a decimal, and the atomic number will always be the smallest whole number that is on the periodic table. Now remember, it's the smallest whole number, not the smallest number. Sometimes the periodic table can give you a value. It's called the electronegativity. Again, we'll talk about it in about a week. But that number is always going to be a decimal, but that one might end up being the smallest. So remember, the atomic number is the smallest whole number, and the atomic mass will be a decimal, and it's going to be the larger number.